before you watch this video, you should attempt all questions in this review package yourself. See what you're good at, see what you're great at, see what you're not so sure how to do, and then watch the video. And as you're watching the video, compare what you did to what I do. And if your answer is right, and any question that you're stuck on, that's fine. When you're working on it your own, you can skip it. And then when you go through this video, hopefully it'll show you how to do it and get you all caught up. And then you know what to do. And then there's a follow-up package afterwards that will give you some more practice on some of the same material. So for this first question, it's measurement. This is stuff we did recently. And we're supposed to be determining the area and perimeter of this shape. Now, a couple of things I notice are it's not a regular shape. It's what we call an irregular shape. So it's not a shape that we have a name for, and it's not a shape that we have a formula for. So we have to use some kind of strategy in order to figure out both the area and perimeter. We'll start with perimeter. Perimeter, I think, is actually the easier one, as long as you realize what the perimeter is. So the perimeter of a shape is if I start in any position, but I'm going to start in the corner to make it easy, and I just follow the outside lines of the shape. That's the perimeter. You remember the example we did in class, the perimeter of a building, walking the perimeter of a yard. That's what perimeter means. It's the length around a shape. If I walked around this shape, how far would I walk? And so one of our strategies that we use for this is we count the sides. So I've got 1, 2, 3, 4, 5, 6 sides, and I'm actually even going to write that down. And I'm going to use that as a strategy because it's going to force me to remember that I'm supposed to add 6 things together. So I'm going to eventually have perimeter equals 1 plus 2 plus 3 plus 4 plus 5 plus 6 things. And it looks like I am actually only given 4 of them. I can fill those in. So I've got 8 from here. I've got 6 from here. I've got 8 again from here. And I've got 22 from down here. But what about these last 2? And this is what a lot of people forget. And they just add the 4 numbers that they're given together, and they don't realize that there's actually 2 more numbers. So this is the most important thing about perimeter, and the main mistake that people make. So now here's where we become a detective, and we have to try to figure out what the other 2 sides are. So I can see that the 2 sides that are missing are this side and this side. Those are the 2 lengths that I'm not given. And so we'll do them one at a time. We'll do this pink side first. And what I notice is that if I think of this line here is the same as this line here, they would be the same length, then this is 6. And then if I think of this line here is the same as this line here, then this is 8. And then if I add those 2 together, 6 and 8, I get 14 total, all the way from the top to the bottom. So I'm going to add in another 14 for side 5. And the way I'm going to find the last side is similar in some ways, but it's a little bit different, because instead of adding 2 sides together, I notice that I've got this length all the way across is 22. So if this is 22 all the way here, okay, so I've gone 22, but then I'm going back 8. So how far have I gone total? That's going to be 22 minus 8, and that's 14. So this side length here turns out to also be 14. You know what? I'm going to color code these. So this is 14, and this is 14. Not that it matters which one's which, but that's what those 2 side lengths are. Okay, and so now I can go ahead and finish this. And I get 8 plus 6 plus 8 plus 22 plus 14 plus 14, and that's 72. I just add them all together in one shot, and I get 72 meters. Okay, so that's perimeter. And I just state the number of sides and make sure I add that many things together. Now the next one, area. I'm just going to draw a line here, and I'm going to do area below. Area is very different, okay? And I have to make sure I don't mix up the two different procedures. So I can't do area the way I do perimeter, and I can't do perimeter the way I do area. So you've got to make sure you get these separate. But for area, what we're going to do is split this up into shapes that we do know the formula of, and we are going to find each of them, and in this case, probably add them together. So what I'm going to notice here is that if I cut this shape, the whole shape, into two shapes along this line, I've got two rectangles. And one of them is 8 times 6, and the other one is 22 times 8. So they're both rectangles. That's length times width. And so area 1, I'm going to call this area 1, is length times width. For area, we always use formulas. So we usually try to write the formula down before we use it. Perimeter, we don't use formulas, but area we do. So length times width, so that's 8 times 6, which is 48. Use your calculator. And if we call this one area 2, we're going to say that area 2 is also length times width. It doesn't always have to be rectangles, right? It can certainly be other shapes. And so in this case, they're both rectangles, so it's just length times width. And that, again, is 22 times 8. And what does that work out to? 176. Okay? And those are both meters squared because that's the unit we use for area. Now, for the total area, I'm going to add them together. And that way, when I get this one added to this one, whoops, this one added to this one, I'll do them in the same color. That's the total area altogether. So this is area 1 plus area 2, which is 48 plus 176. And that works out to 224 meters squared. And that's the first question done. And I've found both the area and perimeter of that figure. Two Pythagorean theorem questions. This is great because they're two questions and they show us both kinds. I'm just going to talk about them both to compare them, to show the important things about Pythagorean theorem, and then we'll do them one at a time. What I notice is, in this case, I'm looking for this side length, and in this case, I'm not looking for that side length. That's the hypotenuse. There's something special, and I'm sure most of you know and are remembering what this is all about. So I know that the hypotenuse is the longest side. It has to be longer than the other two. So I know that these two are going to add up to the hypotenuse. And in this case, it's these two that add up to the longest side. And so, but this is not the one that I'm looking for. I'm not looking for the longest side. I'm looking for a shorter side. So instead of adding, in the case of B, I'm going to end up subtracting. This is one of the things about Pythagorean theorem we want to know is, am I going to add or am I going to subtract? And that has to do with, are you looking for the longest side or not? And then the other thing, if you remember, that you have to think about is you don't just add, because that really wouldn't make any sense. It's not just 50 plus 120. If you think about it, that makes no sense at all. So we got to square everything, and that's what makes the relationship work. So if you watch, this one is y squared equals 50 squared plus 120 squared. Okay, that's how I do that one. You can start like that, or sometimes we just start by doing this. It's the square root of 50 squared plus. And so notice that I'm adding them because I'm looking for the longest side, so I'm adding them. And actually, you know what? I'll do this one right now. And for the next one, it's going to be x squared equals, and it's always going to be the bigger one minus the smaller one, or x equals the square root. You don't have to write both steps. You can start at the second step. It's up to you. Okay, but you'd often see this first step written out first before the second step. But for us, it's fine to do it however you like. Okay, and then I just punch this into my calculator. So if I have a calculator like this, I'll show you. I go 50 squared plus 120 squared, and then I'll hit equals, so I've got that answer, and then I just hit the square root button, and it gives me 130. So this one, the final answer is 130. Okay, 21 squared minus 9 squared equals, and then hit the square root. And this one's 18.97, so x is about 18.97. Okay, so that's Pythagorean theorem. That's one of each type, and the numbers can change, but otherwise you only ever have the type that you're adding or the type that you're subtracting, and you're always squaring everything and taking that square root at the very end. Geometry, again, we just did this. Find the sum of the interior angles of a 24-sided figure. So you remember what we did. This is inside angles. We did a day on this, and what we realized is what you do is you take the 24 and you subtract 2. So I'm going to put my answer on the line here. So I'm going to do some work off to the side. So I take the 24 and I subtract 2 from it. And then when I get that answer, it's obviously 22. I'm going to multiply that answer by 180, and that will tell me the answer that I put on here. So that's 22 times 180. And again, I'm just going to do that on my calculator. And I got 3,960. That's pretty big. So 3,960 degrees. That means all the inside angles of a figure that had 24 sides. That would be hard to even draw, but they would all add up to 3,960. Okay, and it's just that formula where I take that number and I subtract 2, and then I multiply what I get by 180. And then this other question, we talked about this a little bit. If the figure above is regular, what does that mean? That means all the angles are exactly the same. What's the measure of each angle? So now I go back to the 24, okay, and I do that total, which is 3960, divided by 24. Because if they're all the same and there's 24 of them, then I divide by 24 to figure out what one is, and it works out to exactly 165 degrees. So if you had a regular shape that was 24 sides, you'd have 24 angles of 165 degrees. We only have one question here. We'll do some others on other days, but for now we just have one. And I look at this and I can see some different things happening here. I can see that these angles are opposite. So if I needed to, which in this case I don't, but I would know that this is 141 degrees. There's no parallel line, so I'm not using parallel line theorems. There's no triangle, so I'm not using that. But what I do notice is that these two angles are on a line together. And so to find x, I'm going to do 180 minus 141, because this whole thing has to be 180. So I subtract the 141 to figure out what's left. Okay, and that works out to 39, and that's my answer, so I'm going to put it there on the line. Okay. Moving over to a totally different unit, when we talked about a lot of linear relations and rates of change and applications of rates of change and that sort of thing. So tickets for Toronto FC cost $25 per ticket. If you order online, you also pay $12. But that $12 is for all the tickets, okay? So it's a one-time service fee. It's not $12 per ticket. Now, in real life, it might be $12 per ticket. I don't know. This is kind of a made-up question. But for this, it's just $12. Doesn't matter how many tickets. So state the, wrong word, rate and slope mean the same thing, with units. So that's, if you remember back to this, and I'm sure most of us do, that's the thing that's per something. So that's the $25 per ticket. So this is, I'm going to write 25, and it says with units, so that's dollars per ticket. Okay. State the y-intercept or the initial value. I'm going to do this one in a different color. With units, so that's the $12. because that's a one-time fee. That's where it would start. Whether you get 1 ticket, 2 tickets, 3 tickets, you pay $12. Some people think it doesn't make sense. If you bought 0 tickets, you'd pay $0, so there's no initial fee. And that's true, but that's not how the relationship works. So we would still kind of say, even though it's ridiculous, if you bought 0 tickets, you'd pay the $12 service fee. Okay, that's just how the relationship works. Now we're going to write an equation to represent C. So I'm going to get C equals the $12 one-time fee plus ordering N tickets online. So that's 25 times N. So $25 per ticket. If I buy 10 tickets, it's 25 times N plus just the $12. Now here we go. We're going to use it. Use your equation to calculate the cost of ordering 9 tickets. Okay, so that means N is 9. That's what it's telling me. So the cost, and it's saying show, it's trying to say show proper steps. So we're going to try to do this the nice way. 12 plus 25 times 9 tickets. Remember in linear relations, it's all about where does it start and what's the change. And so that's exactly what this question is talking about. So I'm going to do 25 times 9 first, and that's 12 plus 225 plus if you're spending $225 anyway, what's an extra $12, right? So 237, and then I'm going to do my therefore statement and put units in. Therefore, 9 tickets would cost $237. Okay, I hope that's clear. That's some work on linear relations, the change or the rate, and the initial value, making an equation, and then using our equation. Oh, there's some more stuff on linear relations here and applications of linear relations. So again, Teddy is joining a new tennis club. He's got 3 options that he can choose from. The cost of each is outlined. That doesn't make any sense. Outlined below. Okay. So for every one of these, it's all about where does it start and what's the change or what's the rate. So each one of these, Club ABC, is going to give us that information. The first one says an initial fee of $150 plus $1 per use. So there's my change and there's my initial fee. That's pretty straightforward. What does Club B mean? It means a flat fee of $250. So there is no cost per use. Okay. You have to understand that when you read through. A flat fee of $250 means no matter how many times you play, you pay $250. And Club C, all it says is $5 per use. So I guess that means it has a rate, but it has no initial fee. But it's more per use, a lot more than $1 per use, right? So if you just think about it, each one of these is going to be better for different people. If you're only playing once, you probably don't want to use Club A or Club B because you're going to pay a lot of money up front. If you're playing a whole bunch of times, like, I don't know, let's say 2,000 times, you probably want to go with Club B because it's just a flat rate. So let's take a look at each of these. Club A, the cost will be the $150 plus $1 per use, so 1 N, although we often don't write the N, so it'd just be like plus N, but that is like plus 1 N. Okay. Club B, this one's tricky. And you could write it this way. C equals the initial fee, the flat fee, plus 0 N. Now, when I multiply by 0, it's gone. So in actuality, it would look like that. My real formula would look like C equals 250. That's it. The cost is 250. Flat. It doesn't change. So that actually makes sense when you think about it that way. But if you like, you could write it like that, and that would be fine. And then Club C is $5 per use. So Club C, the cost is going to be $5 times the number of uses. So 5 per 5N. That's where the rate always goes beside the N like that, right? plus 0 because there's no initial. And again, I don't need to put that, but if you want to, you can. Okay. Classify each as direct or partial variation. So if you remember what that means, it basically means, is there an initial fee or not? So in the first one, there is, so this is partial. In Club B, there is an initial fee, so this is also partial. In Club C, there's no initial fee. It's only based on the rate, so that means it's direct. And that means the math of these ones works out a little bit differently in each case. That's why we have different names for it. That's an important thing to remember. Partial or direct. Partial, sorry, I'm going to start with direct. Direct means no initial fee. Okay, and partial means it has an initial fee. Graph each in the space provided. So let's start with A. A starts at 150, okay? And then I'm going to do this. It's $1 per use. So that means if I went to 50 uses, I would add $50. So that's an easy point to find because that's 150 up $50 to 200. Another 50 uses is going to take me to 100, and that's going to take me up to 250. Another 50. Kind of nice to do at least 2 points instead of just one extra point. Okay. Oh dear, the line's red. We're going to have to fix that. Whoops. That is not what I meant to do. Fix that and make it look nice. Here we go. Okay. I am going to use a different color for the next one though. And we'll do Club B. Club B is, oh, so this is A. I'm going to say that. Club A. So B is 250 flat, so it starts at 250, and look, no matter what, how many you use, you're going to pay $250. So it actually, you know, it's funny that we call it a flat rate, and then it actually is a flat line on the graph. Okay, and that one was B. And then C is 5N, so that starts at 0. And let's see, what would be a good one? If I used 20 times $5 is 100, so I'd pay $100. 40 times $5 is 200, so I'd pay $200. 60 times, oh, I can put that one in. 60 times $5 is 300, so I'm going to pay $300. Again, if I do a few points, I can make sure they line up in a perfect straight line and make sure that I kind of did it right and I didn't mess anything up. Okay, and again, let me change this color and call this one C. So there we go. We've got A, B, C. We've got our 3 graphs. We see one is direct variation because it has no official fee. That means it goes through 0 down here, and the other 2 are partial. They do not go through 0. They start up there somewhere else. And A starts at 150 and goes up, and B starts at 250 and it's always 250. So we can see in the long run, B is a lot cheaper. B becomes cheaper right there. In this section, A is the cheapest because it's the lowest. And over here, C is the lowest because it starts lowest. If you're only playing once, it makes most sense to use C. Okay, that's it for the first package. So I hope now that you've tried it yourself and you've watched the video, that clears up any issues that you have. Watch the video again. If you didn't understand one question, go back and watch that question. There's another package that you can work on to try some more practice by yourself. Okay, and then there will be more stuff to do in class together and more packages to do independently following this one because this is just day 1. Good luck.